This week on the podcast, the first of a two-part interview with anthropologist Carl van Schaik on animal intelligence. Historian and writer William Lanowet discusses an upcoming TV program about the beginnings of the nuclear era, and Scientific American editor-in-chief John Rennie reports on a recent Sustainable Development Conference. Plus, test your knowledge about some recent science in the news. First up, Carl van Schaik. He's the director of the Anthropological Institute and Museum at the University of Zurich, and he wrote the article, Why Are Some Animals So Smart? In the April issue of Scientific American magazine. I cleverly used a telephone to call him at his office in Switzerland. Professor van Schaik, thanks for talking to us today.
Glad to be here.
I read your very interesting, very entertaining article in the April issue of Scientific American about intelligence among animals. Why are some animals so smart is what it's called. And you talk right up front about how traditional explanations for what drives intellectual ability in animals have included the requirements of social relationships or the requirements of a challenging environment. But you think you've hit upon something that doesn't get a lot of discussion as a key to animal intelligence. Talk about that.
Yeah, but first let me say I'm not proposing an alternative because you still need those kinds of benefits from being smart. But what I'm saying is that under particular conditions, it's a lot easier to get smart than under others, and that is because we have so far really ignored the role of social learning. And that means that if you can acquire skills in particular that are not easily invented through social learning, you might say the signal-to-noise ratio of exploration goes up orders of magnitude. And in other words, with the same amount of brain tissue, you can learn many, many more skills. You learn them much faster, much more efficiently. And as a result, it's easier for natural selection to say, hey, let's enlarge this brain size because clearly this is producing fitness-enhancing skills. And so basically what I'm saying is that if you admit that culture is present, then culture really raises the level of intelligence of animals almost by orders of magnitude.
What exactly do we mean by culture when we're talking about animals?
Well, exactly, when we're talking about animals, because culture is defined in many, many different ways. But if you strip away all the paraphernalia, then really what culture is about at its core is about innovations that are not encoded in the genome somehow and are passed on not by genetic transmission and are not sort of shaped by natural selection, which is the normal stuff of evolution, but it is transmitted socially through social learning. So it's things that have as little to do with genes as possible.
Let's talk about the specifics. You've been studying these groups of orangutans in Sumatra. What do we see in terms of culture in one group versus another, and why?
Well, it turns out there's a lot there, but that doesn't always meet the eye. So what we started out with was sort of the paradox that we saw in these especially these swamp populations. We saw several tool users that were shown by everybody in the population. So the anthropologists would say they're customary, and were rather complex looking, and yet didn't occur anywhere else.
And what were the orangutans using the tools for? What kind of tools did they have, and what did they use them for?
Right. Yeah, you shouldn't think of pliers and hammers and so on.
Right.
These are simple stick tools. So basically, they grab a little branch or a twig, and they work on it a bit to make it the right size and thickness. And then they either go into tree holes to extract either parts of nests of social insects or honey, because there's some nice bees in there that don't sting, but have nests in these tree holes, and so you can get the honey out. They also extract the seeds from a fruit that is really very unpleasant to touch because it has stinging hairs around those seeds. But if you apply short sticks, you can actually sort of dislodge those seeds from their pedestals and drop them into your mouth, which is what they do. And then they have a few others that are tool uses that are less common. So these are the main ones, and they may sound rather simple to you, but orangutans elsewhere can't do the job.
They're actually using the sticks as a lever to open that seed pod?
Yeah, well, it's more. There's some pictures in the article. It's hard to describe without actually showing images. But so basically, the seeds are sitting in a row. The fruit dehisces, as they say technically. So there's a crack, and you see the seeds there. You could, in theory, stick your finger in there and then rip out the seed. But if you do that, you get all these needles into your fingers. This is actually what the birds do, because birds, of course, have keratinous beaks, so they don't have to worry about those things. What the orangutan then does is wiggle with that stick until that seed actually comes loose.
So it would seem to intuitively make sense that if you don't have to, if an individual, regardless of what species that individual is a member of, does not have to reinvent the wheel, so to speak, with each new lifetime, that you would have the potential for much greater intelligence within a population,
right,
by taking advantage of the innovations that other members of the population have made.
That's exactly the idea in a nutshell. Yeah. And if you apply this to people, everybody says, of course, duh, of course, that's how people learn. But for some reason, and I've been thinking about why that would be, we've thought that this is not the normal state of affairs in animals. And I suspect it's because when we do cognition experiments with animals, so we try to measure their cognitive abilities, we put an animal individually in a cage or some kind of an apparatus, and we ask it questions, and we see how well it performs. We exclude the social factor for all kinds of good experimental reasons. But we sort of take the essence out of what's probably extremely common in nature.
We'll have part 2 of the interview with Carl van Schaik next week. His article, Why Are Animals So Smart?, is available free at our website, www.siam.com. Want to share some thoughts about the podcast? Let us know what you think by participating in our survey at www.siam.com/research. Now it's time to play Totally Bogus. Here are 4 science stories, but only 3 are true. See if you know which story is totally bogus. Story 1. A new study found that praying for heart surgery patients had no effect on the patient's medical outcomes. Story 2. The coal-powered airplane? Researchers have developed a technique to make jet fuel out of coal. Story 3. A study basically modified the arcade game Whack-A-Mole to see the effect when people had the chance to whack American politicians and famous dictators. And Story 4. Researchers report the discovery of a previously unknown species of mold that seems to grow only on wigs, and even more specifically, only on men's wigs. We'll be back with the answer, but first, William Lanowet wrote the article The Odd Couple and the Bomb for the November 2000 issue of Scientific American. It's about the strange relationship between Leo Szilard and Enrico Fermi and their attempts to create a controlled chain reaction. On Monday, Lanowet will be featured on a new program on the History Channel. To find out more about that, I called Lanowet at his office in Washington, D.C. Hi, Bill. How are you? Thanks for talking to us today.
Delighted to be here, Steve.
What is this History Channel show, and how are you on it?
The show is called Einstein's Letter, and it's first about a 1939 letter that he signed to President Franklin Roosevelt, alerting him that the Germans may be making nuclear weapons. For a number of years, I've written about Leo Szilard, who in fact prompted this letter and who in fact thought up the chain reaction that they were scared of at that point.
The Einstein letter to Roosevelt is pretty well known. Are there any surprises that are going to come up in this program people might not know about?
I think so, Steve. The most famous Einstein letter is in 1939, but in the spring of 1940, when Szilard and Fermi were not receiving the money that they were promised, they wrote a second letter, that is Einstein and Szilard, in effect blackmailing the federal government and saying, if you don't send us the money to do research at Columbia, we're going to publish our results. And then there was a third letter in 1945 where Einstein says to President Roosevelt, you should see Dr. Szilard about the post-war consequences of this project that they're working on. But FDR died before he saw that letter, but Szilard did take it to the Truman White House, and that led him ultimately to talking to the incoming Secretary of State about control of the bomb.
And you've actually co-authored or co-play-written a play about that episode in American history.
That's right. It's called Uranium and Peaches. I wrote it with Peter Cook, who's a Hollywood writer. Not the Peter Cook, but a very good playwright, Peter Cook. It's the scientist who made the bomb and wants to stop it meets the politician who can't wait to use it.
How did you get to be so familiar with this material? It's obviously something you've been doing for many years.
It started in the early 80s when I was doing an article for the Atlantic Monthly about the nuclear breeder reactor and was trying to trace its origins and found that they were traced to a guy named Leo Szilard, who I never really knew about. He thought up the chain reaction. He thought up the concept of critical mass. He then thought up and named the breeder during the Manhattan Project. The first breeder was built in Michigan, and it was named for Enrico Fermi. And I said, what happened to Leo Szilard? And that got me on the trail.
And in your article, I recall from 6 years ago almost at this point, but they were a fascinating combination of personalities. It's really the Oscar and Felix of physics.
It really is. Szilard was whimsical and creative, and Fermi had very strong insights that he tested very methodically. And they were real opposites, but they did stick together and did get the United States on the trail to the bomb.
Didn't Szilard, was it in your article that he would sit in the bathtub all day thinking until 2 p.m.?
Most mornings he spent in the bathtub, and he really enjoyed free associating and just daydreaming. He said leisure was very important for any scientist to really come up with good ideas, and he certainly put that to practice.
I think you're going to be widely quoted by any scientists who might hear this as they explain to their department chairs where they were for the last few days. What is it that you do for your actual living? I know that as a playwright and a contributor to various magazines, that's part of what you do. But your day job, what is that?
For about 15 years, I've been a senior analyst at the U.S. Government Accountability Office, the GAO. We're the investigative arm of Congress, and I've been doing energy and science issues, much as I was doing as a journalist, but with the power of subpoena. Makes it a lot of fun.
Tell everybody when this program is going to be on the History Channel.
It's going to be on Monday night, the 10th of April at 9 o'clock Eastern, 8 o'clock Central. It's one of 10 programs that they're doing on days that they say unexpectedly changed America.
And William Lanowet, you're one of the featured talking heads on this show about the letter.
I think if you write about an obscure guy long enough and he comes out of the shadows, you become an instant expert. And I'm very happy to talk about Leo Szilard.
Terrific. Thanks a lot, Bill. Appreciate your time.
Thank you.
William Lanowet's Scientific American article from 2000, The Odd Couple and the Bomb, can be purchased at our digital archive, www.siamdigital.com.
Novartis, committed to making innovative medicines for a world of patients and their families. Online at Novartis.com. Novartis, think what's possible.
Now it's time to see which story was totally bogus. Here are the 4 stories again. Story 1, prayer did not improve patient outcomes. Story 2, jet fuel from coal. Story 3, a version of whack-a-mole was used to study attitudes toward politicians. And Story 4, a species of mold grows only on men's hair pieces. Time's up. Story 1 is true. Heart surgery patients who were prayed for did not fare better than patients who were not prayed for. That's according to a study in the next issue of the American Heart Journal. Story 2 is true. There's coal jet fuel, and thank goodness you don't have to actually shovel coal during the flight. No, they can actually make jet fuel out of the coal. Penn State researcher Harold Schobert announced last week at a meeting of the American Chemical Society that he'd made jet fuel that's half from bituminous coal, and they've successfully powered a jet engine with it. The mix can actually go as high as 75% from coal. And story 3 is true, a whack-a-mole study. by a Stanford University researcher and a Washington Post pollster looked at the effect of physically whacking images of politicians and dictators. The researchers reported their results in the Post last week. Surveyed after the whacking, whackers pretty much felt the same way toward various politicians as they did before. Interestingly, however, total scores could have been higher, but whackers went out of their way to whack members of the other political party and to spare their own party people. And the good news, everybody still hates Hitler. He was the most whacked figure. All of which means that the story about the species of mold that grows only on men's toupees is totally bogus. But I wouldn't have been shocked to hear that this story was true, because the world of biology includes critters that are much weirder than a mold that would only grow on men's wigs. For example, and this is true, there's a species of leech that seems to mate only in, how shall I put this, the nether regions of hippos. Hey, to leech his own. Next up, Scientific American Editor-in-Chief John Rennie. He just attended a major meeting on sustainable development. To get the lowdown, I called him at his office in New York City. Hi, John. How you doing today?
No, just fine. Thanks, Steve.
You just returned from the State of the Planet 06 Is Sustainable Development Feasible conference.
That's correct. This is actually the fourth in the series of State of the Planet meetings that has been organized by the Earth Institute at Columbia University for the purpose of looking at the issue of sustainable development.
So the subhead for this whole talk is sustainable development feasible? This whole conference, I should say. So is it? Is sustainable development feasible?
Well, maybe not too surprisingly. I would say that the implicit answer was yes. The point of a meeting like this is in part to try to explain just what hope there really is for trying to make development sustainable. I guess one of the things, of course, that we also had to address at this meeting was what is sustainable development, and that is something that's open to a lot of different interpretations. But basically, sustainable development is it's an ideal of trying to promote prosperity around the world while also recognizing that we need to preserve the sort of valuable services that the natural ecosystems provide because they are an essential strut of the world's economy. So this really marks a big intersection of work going on between people involved with the decision-making involving trying to alleviate global poverty, but also trying to deal with environmental issues, including global warming, and also, of course, a lot of scientific and technological issues.
I know that we're involved, Scientific American Magazine is involved in some official capacity with this conference. What is that?
Well, we have at Scientific American, we've sort of partnered unofficially with the Earth Institute on a variety of different projects over the past couple of years. I was actually a moderator of a concluding session, and Jeffrey Sachs, who's the director of the Earth Institute, is also joining Scientific American as a new columnist on the subject of sustainable development with the June issue.
Who were some of the other big names there in addition to Sachs, and what were some of the highlights of what they said?
Well, it really was quite an illustrious panel of sorts pulled together over the 2 days of the meeting. People addressed a lot of different topics having to do with global poverty and particularly global climate. I think one great presentation came from Sir Partha Dasgupta, who's a professor of economics at the University of Cambridge. He pointed out that one of the reasons why economists have traditionally tended to devalue some kinds of environmental issues is that when they look forward, they usually are assuming we're looking at a global economy that is continuing to grow. As a result, they apply what we call a positive discount rate in their consideration of the problem, which basically means that if we defer some of these problems to the future, that it would take a smaller proportion of our wealth to be able to alleviate them than trying to put up a lot of money right now. What Partha Dasgupta was pointing out, though, is that no one ever takes into account the very real possibilities of declining consumption per capita, which, of course, can mean that you could have a negative discount rate, and that in the future it will be much more expensive than for you to try to deal with some environmental issues right up front.
I see that Peter Singer was one of the presenters at the conference from Princeton. He's a really interesting guy. I mean, he is probably the foremost philosopher of animal rights, in a serious way, who's out there. So what was it that he had to say at the conference?
Well, it was very, very interesting.